Hey guys, what's up? Mr. Miller here, bringing you another tutorial video. In this video, we're going to look at using the quadratic formula, but now we're going to involve quadratic equations that might have solutions that are complex or imaginary. In other words, we're going to have the letter I in our answer. Or we might have to do some more simplifying after we plug in our numbers and get an answer. And at the very end, we need to check our answer to see if we can boil the numbers down to something smaller. And this will all click once we start doing an example or two together. So let's just go ahead and get right into it. Just to review, if you have a quadratic equation in this form, ax squared plus bx plus c equals 0, then you can find the solutions to that quadratic equation by using this monstrosity of a formula. It's not all that pretty to look at, but the beauty of the quadratic formula is it always works. It will always give you the correct solutions if you plug in the correct numbers, you do the correct math behind it, the correct arithmetic, and you simplify correctly. It will always work. All right, so let's say that we want to solve 6x squared minus 4x plus 1 equals 0. This is a beautiful quadratic equation, and what makes it beautiful is, first of all, 0 is already on one side, and we have our exponents getting smaller and smaller from left to right. 2z's, 1z's, no z's. We can dive right in to quadratic formula. To do that, we need to know, well, how much is A, how much is B, and how much is C. So let's see, what do we got going on here? A is 6, B is negative 4, and C is positive 1. We're going to dump those numbers into quadratic formula. I'm going to rewrite the formula. All right. In this formula, notice that there's a minus on the first b. That means take the opposite of whatever b is. B is negative 4 right now, so its opposite is going to be positive 4. In the quadratic formula, inside the square root, inside the jail cell, I plug in my original b value. My original b value is negative 4. Minus 4 times a times c. A is 6 and c is 1, and this is all over big fraction bar, 2 times a, and a is 6. All right, let's do it. Let's simplify this monstrosity. So now we get plus or minus, well, negative 4 squared means negative 4 times negative 4. That's 16. Minus, well, 4 times 6 times 1 is 24. Okay, you could also think of it like this, and I recommend doing it this way actually. Take the minus with the number that comes after it. So say not minus 4, but negative 4 times 6 times 1. That's going to be negative 24. All over 2 times 6, which is 12. What is 16 minus 24? What do you got? What are you thinking? Are you thinking negative 8? Because I'm thinking the same thing. Great minds think alike. Negative 8 is correct. Basically, everything stays the same except for inside the jail cell. Now I get negative 8 inside over my 12. And what we want to do now is see if we can break this answer down further. First of all, notice that there's a negative in the square root. We can deal with negative numbers in our square root now. We've learned how to do that. Take out the negative, and we're going to replace it with I. 4 plus or minus, well, negative 1. Now what about 8? How does 8 break down? What's the largest perfect square that goes into 8? 4, right? And its partner would be 2 because 4 times 2 would take me back to my 8. Okay, and this is all over 12. So 4 plus or minus. Okay, now let's take a look at this part right here, the -1 and the 4. The square root of 4 is 2. I'm going to write the number first. The square root of -1, well, that's I. And then we get square roots of 2 over 12. Here at the very end, we want to look at the heart of the problem, or the answer, I should say. The heart of the answer. I call this the heart. In other words, I leave the stuff inside the square root alone, and I want to see if I can break 4, 12, and 2 down further. 4, 12, and 2 down further. What number goes into all three of those evenly? If you're thinking 2, you are correct. I want to divide each of these by 2. Divide by 2, divide by 2, divide by 2. Leave the number in the square root alone. So here goes our final answer. 4 divided by 2 is 2. 2 divided by 2 is 1. I'm going to leave off the 1. What's going to come after that is an I, square root of 2. All over 12 divided by 2 is 6. And there we go. We have got our answer to our quadratic equation. All right. If something in the example has confused you, I want you to call me over and ask for clarification. You don't have to watch the video straight through if you have questions on stuff. Call me over, I'll be glad to clarify. All right, our next example. Notice that this one doesn't have 0 on one side, and it's not in standard form. So what we need to do first is get 0 on one side. And there's a couple of ways you can do it. I prefer to keep the squared part, this part that's on our left in this problem, positive. So even though I'm going to have to move more stuff, because I'm going to move 2x and -9 here in a moment over to the other side, it's generally a good idea to keep your leading term positive. So to move these over, we're going to subtract 2x from both sides. And then since this is a -9, we're going to need to add it. So these go bye-bye, those go bye-bye, and we're left with 0 on the right, which is what we want because that's part of standard form of a quadratic equation. 0 on one side, and then our exponents are going to get smaller and smaller as we go from left to right. Now we want to solve this. What I would like for you to do is to try this problem on your own. After you've tried it on your own, check your answer and the work, and if you have questions, call me over. Please smash that pause button right now and try to work it out. All right, check it out. The answer that I got is x equals 1 plus or minus I square root of 17, big fraction, all over 2. Let's walk through how I got that. A is 2, B is -2, C is 9. So I always base A, B, and C off of where my equation is set equal to 0, and the exponents are getting smaller from left to right. 2z's, 1z's, no z's. Plug those numbers into this monstrosity of a formula and simplify stuff. When B is negative, right away the sign is going to flip to positive. If B starts off positive, the minus would stay on whatever the number is. Pretend B is 4. Well, the opposite of 4 is -4. Simplify inside the square root. -2 squared is 4. -4 times 2 times 9 is -72. 2 times 2 is 4. Up, up, and away. When we subtract 4 and 72, we get -68. Take out the -1. The biggest perfect square that goes into 68 is 4. Its partner would be 17. The square root of -1 is I. The square root of 4 is 2. So typically when we have I paired with a number, we like to put the number first and the I after it. That's a convention. And now I just look at the heart of the matter, and I see if the heart of my answer can be simplified any. I can divide each of these by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And so my final answer is 1 plus or minus I square root of 17. That square root of 17 came from 4's partner, because 4 times 17 would take me back to, if we ignore the minus here, to the 68. All right, and that's all over 2. Okay, I hope you have gained some insight in this video on solving some more complex quadratic equations. And at this time, I would like you to please bring your notes up to me so I can take a gander at them. And thank you for watching. I appreciate your time and your efforts. Take care now. Bye-bye.